I want to look at a few more examples. The next example is really talking about interpretations of the confidence interval. So in 22, a 90% confidence interval for the number of hours that full-time college students sleep during a weekday is, and it's given us the lower bound of 7.8 and the upper bound of 8.8. Which of the following represents a reasonable interpretation for the result? And then if it's not reasonable in one of the A, B, C, or D, then explain why it's not reasonable. A, 90% of full-time college students sleep between 7.8 hours and 8.8 hours. This is not a good interpretation of that. This is implying that we're talking about the individuals, and remember, confidence intervals are about the mean. So this is talking about individuals, and it's not the interpretation of what the confidence interval is. It's saying something completely different. If we look at B, B says we are 90% confident that the mean number of hours of sleep that full-time college students get any day of the week is between 7.8 hours and 8.8 hours. So if we look at this one and we compare to our scenario, the scenario is talking about weekday, so Monday through Friday here. This is talking about any day of the week. So these aren't comparing the same thing. So it's a very subtle difference, but it makes a difference in that interpretation. So that statement's flawed because we're not talking about any day of the week. We're talking about just weekdays based on the scenario given to us above. C says there is a 90% probability that the mean hours of sleep that full-time college students get during a weekday is between 7.8 and 8.8. So this really goes back to the first video we did on confidence intervals. This is a very common misinterpretation of what the mean of what that confidence interval means in the context of the problem. So we don't have a 90% probability that the mean hours of sleep is between 7.8 and 8.8. This is implying that the population mean varies rather than that the interval is actually going to vary. So D is our correct interpretation. We are 90% confident that the mean hours of sleep that the full-time college students get during the weekday is between 7.8 and 8.8. We don't actually know what that mean value is going to be. The confidence interval just gives us, it narrows down where the mean could live. So we're saying we're 90% sure that that mean has to be between those numbers. We just don't know what that mean actually is. So once again, if we were to look at 100 different samples and we were to look at the 100 confidence intervals that would come out of those 100 different samples, then we would expect 90 of those samples to actually have that true population mean. And in this case, we're talking about the mean time of sleep during a weekday. We would expect 90 of those samples, of those 100 samples, to have the mean, and we would expect 10 of them not to have the mean. So be careful about the interpretation of what that confidence interval means. And then let's look at 31. 31 is giving us a data set, and they're asking us to find the confidence interval, and we're going to use StatCrunch to do that. So we have pH values for rain for 12 samples. The normal probability plot suggests that the data could come from a population that's normally distributed. That's important since our sample size is so small. A is asking us to determine a point estimate for the population mean. So the point estimate here would be the sample mean. The sample mean, we know, targets the population mean. So let's take all of these numbers and let's plug them into StatCrunch so that we could find the mean here. I'm going to type them into that first column. We do have 2 of the 4.77s. We do need to type both of those in. So now that we have everything typed in, so remember to do this in StatCrunch. I'm going to go back a screen. You go to Stat, you go to Summary Stats. It's not going to work on my tablet like it would on a computer, so your screen is going to look way different than mine. Mine's just not going to give me something nice. Well, it's not quite as different as I thought it would be. So we want the mean. Here's our mean, 4.8925. So then our standard deviation, going back to this, was 0.3194. So when they ask for the point estimate, they're asking for that mean. If we wanted to do this by hand, we would need the standard deviation and the t-statistic, but we're going to use StatCrunch to help us do that. B is asking us for a 95% confidence interval. So if we go back to StatCrunch, we're going to go Stat, T-stats. This is a 1 sample. This is with data. And our data is in that first column. And we want to compute. Oops. Let's try that again. I forgot to choose confidence interval. Confidence interval. And we want a 95% confidence interval. And then compute. So our confidence interval is 4.690. I'm going to round to 3 decimal places to 5.096. So then our interpretation, we could say something to the effect of, we are 95% confident that the mean pH value, pH of rainwater in Tucker County, West Virginia is between 4.69 and 5.096. So C is asking us to change that confidence interval to 99%. So we're going to go to Stat, T-stats, 1 sample. This is with data again. Everything's in my first column. We want to do confidence interval and compute. So you can see how that's changing that confidence interval. So 4.606 to 5.179. So then our statement would be really similar to the one over here. We would just change it to 99%. So we are 99% confident that the mean pH of rainwater in Tucker County, West Virginia is between 4.606 and 5.179. So changing that confidence interval really changed that margin of error. We can compare those margin of errors again. If we were to take the upper bound minus the lower bound divided by 2, here it's 0.203. And here is 0.287. So we increased from 95% to 99%, and our margin of error increased. So you can see that relationship going on there. And then let's look at 43. So here they're asking us for a sample size. So they're telling us that in a recent Gallup poll, they asked Americans to disclose the number of books that they read during the previous year. They're telling us S is 16.6. And they're asking us how many subjects are needed to estimate the number of books Americans read the previous year within 4 books with 95% confidence. So that formula to figure out N was on one of our previous slides. It's N equals the critical value times S divided by error, and we're squaring it. Notice they're using a Z critical value here. And that's just going to make life a little bit easier. We don't have to worry about degrees of freedom, which makes sense because we're looking for N. We can't really find the degrees of freedom there. So if we're looking at 95% confidence interval, and we know alpha is 0.05. So we want alpha over 2 in this tail, which is 0.025. So if we were to use that calculator and do the Z calculator, the normal calculator, we would get 1.96 for that critical value. So then N would be 1.96 times our standard deviation divided by our error. And we want to be within 4 books, so there's our error. I'll write that up here. So if we were to type that in the calculator, remember we have to round this up. So we're going to get 67. We would need 67 people in our survey to be accurate within 4 books. A is asking us, what if we want to be accurate within 2 books? So we're changing that margin of error to 2. Notice the critical value is going to stay the same because our confidence is still 95%. So the formula is going to be a little bit different. If we want to be accurate within 2 books, then we're going to need 265 people. So you can see that if we want that margin of error to be smaller, then we have to increase that sample size. So that's what C is asking. Decreasing that margin of error is going to increase that sample size. And if we look at how it changed, this is almost 4 times the amount of what this is because we decreased that error by 1/2. And then D is asking, how many subjects are needed to estimate the number of books that Americans read in the previous year with 4 books, but we're changing that level of confidence to 99%. So 99% means alpha is going to be 0.01. So our critical value is going to change. And if we were to type this in our calculator or into StatCrunch using that normal feature, we would get 2.58 for that critical value. So our N is equal to 2.58 times S divided by our error, which is 4. And then we're squaring that. So we would need about 115. So if we wanted to compare this to part A, we increase that confidence interval, which means that we had to increase that sample size. We went from a 95% confidence interval to a 99% confidence interval. So you can see all those relationships going on between the confidence interval and how big the sample has to be versus how you want that error to change. So there's lots of relationships between here.